गाड़ी से पैक लाना है. Today we are going to discuss stereoisomerism. There are two types of isomerism we know. Number one is structural isomerism. The other one is stereoisomerism. Structural we have already discussed in detail. Today's topic is stereoisomerism. In stereoisomerism, the two compounds which show the phenomena of isomerism have same molecular formula, even same structural formula. What is the difference then? Yes, their orientation in space, right? So please write down the compounds having same molecular formula, same structural formula, but different orientation in space. Are known as stereoisomers. And this phenomena is known as stereoisomerism. And there are two types. There are two types of stereoisomerism. Number one, cis-trans or geometric isomerism. And number two, optical isomerism. Number one, okay, cis-trans and geometric isomerism. Cis-trans or geometric isomerism. Okay, now in this case, the compounds have the same molecular formula, same structural, but what is the difference? The orientation in space is different. Now, what is this meaning? The first type is the cis-trans. In this type of isomerism, when there is a double bond between two carbon atoms. Now listen everyone, if there is a single bond between two carbon atoms, so actually these carbons keep rotating. Like if Cl is here, H is here, in a short while, it goes like this. The Cl goes up and H goes down. So this carbon actually keeps rotating when there is a single bond. So in this type of the compounds where there is no single bond, there is no free restriction. So there is no type of cis-trans isomerism. But on the same side, in the same case, when there is a carbon-carbon double bond, we learned it. Whenever there is a carbon-carbon double bond, the free rotation is restricted. Right? And for example, these two chlorines are on the same side of the double bond, and on the other side, these chlorines are on the opposite side of the double bond. So you see there is a difference now. Look at this. Now, if you look at the double bond, so these two chlorine, now as this carbon has restricted the free rotation because of double bond, so it cannot switch. So as long as there is a situation like this, that first and second carbon has the chlorine on the same side of the double bond, they are known as cis isomer. And in this case, when they are on the opposite side of the double bond, this is known as the trans isomer. This is cis and this is what? Trans isomer. Okay, so one is cis and one is trans. Cis means same and trans means opposite. So this only generates when there is a carbon-carbon double bond. So whenever there is a carbon-carbon double bond between two carbon atoms, the free rotation is restricted. And as soon as free rotation is restricted, they may originate two different orientations. The one in which the similar atoms are on the same side of the double bond, on the other similar atoms are the opposite side of the double bond. So if you look at these two compounds, I'm going to erase this. If you look at these two compounds, so both these compounds' molecular formula is C2H2Cl2. Both these compounds' structural formula is the same. This is 1,2-dichloroethene. And the same 1,2-dichloroethene. So there is no difference. Okay? Both of these compounds have same molecular formula, same structural formula. The only difference is the orientation, right? Because one is a double bond ke ek taraf, one is opposite side. And this only happens with a double bond, yes, because free rotation sirf kaun restrict karta hai? Double bond restrict karta hai. And how these two compounds become different, I can give you an idea about this. Look, why? Why these two compounds are two different compounds with different set of properties like different melting and different boiling points? Because look, in this case, this bond is polar. Obviously, carbon or chlorine bond is always polar due to the difference of electronegativity. But in this case, the trans isomer, they are opposite to each other, so they cancel out each other's polarity. So trans 1,2-dichloroethene is actually a non-polar molecule. When there is a non-polar molecule, only dipole-induced dipole forces as intermolecular forces. But in this case, they can't cancel out the polarities. You see, the both polarities are in the same direction. Once they are in the same direction, they can't be cancelled. So therefore, it's a polar molecule. 1,2-cis 1,2-dichloroethene is a polar molecule. When it's a polar, it has two forces, dId and dAd. So its melting point, boiling point is obviously higher as compared to that one. Okay, so this is what we need to understand. When they become cis and trans isomers, actually they have a different set of properties because of different polarities, right? So that's why they become two different compounds with the same set of molecular formula, same structural formula, everything is the same, just orientation in space is different, right? And this only happens when there is a double bond. Until unless there is no double bond, so it means there is no two sides of it, right? So if you look at this, for example, now, so there are two conditions. So I'm going to write them. There are two conditions. There are two conditions, in short, for the cis trans to exist. Number one, you know, is a carbon-carbon double bond. Obviously, until it's not there, there's no free restriction on the free rotation. So basic cheez to ye hai. Does all the carbon-carbon double bonds can have cis-trans isomerism? Answer is no. The second condition which is required is this. Look, if a group A is attached with one carbon, there should be group B. If there is a group C, there should be group D. So two different atoms are groups with the same carbon having the double bond, right? So two different atoms or groups must be attached with one carbon. To have cis and trans. Okay, so until there is no double bond, no free rotation, no restriction in the free rotation, and until the same carbon have two different atoms. Like if A is one, other should be B. दोनों A नहीं हो सकते. दोनों मतलब same atoms or groups नहीं हो सकते. Right? For example, now let's see the examples. मैं भी explain करता हूँ. Number one, okay, butene. Can you please draw the structure of butene and see is there any cis and trans isomer for this? Now, butene mean 1, 2, 3, 4 carbon. Please pay attention. Double bond is here. So it is CH3. It is CH3. This is CH. This is CH. Because cis में दो forces of fractions होती हैं. Yes, so double forces, the more forces of fractions increase. But now look at this point. Would you please stop writing? I'll give you the time in the end to write. Now I need your attention. Now, cis butene, does it have a cis trans isomerism? Yes or no? We have to see. Now let's draw the carbon-carbon double bond. ऐसे ही है. So what is with the first carbon? And what is with this CH3? So are these two different groups? One H and one CH3. On the other side, what is this? H and CH3. Are these two are also different? So yes, it will have cis trans isomerism ka phenomena. And this isomer which we have drawn here is what? Cis butene, right? This is cis butene. Now the trans is easy once you have made cis. First carbon, I'm not going to change anything. In the second carbon, I'm going to put H on the top, CH3 down, right? So this will be what? Transbutene. Okay, so yes, butene will have a phenomena of cis and trans isomerism. Number two is pentene. Will it have? Look at this, pentene. So 1, 2, 3, 4, 5. Here is pentene. We have to focus whenever they ask you to draw the cis and trans isomer. Please focus only those two carbons which are having double bond. So if I write these two carbons here, what is attached with the left carbon? Hydrogen and CH3. What is with the right? Hydrogen and CH3. Okay, so both sides must not be the same, may or may not be the same, but the hydrogen is the same on the same side as the double bond. So ये कौन सा हो गया? Cis pent doing. Trans, I said it's easy. The first carbon I always draw the same. You can do it. You can also change the first swap, the first one. In the second carbon, I'm going to put H on the top and CH2, CH3 underneath. So that will make trans pentene. Is it clear? Yeah, one of the carbon is twisted. Number three, look. Look, if it is a but-1-ene, what about this? If it is a but-1-ene, if it is a but-1-ene, look at this. 1, 2, 3, 4. This is but-1-ene. But-1-ene. Now look at the carbons, please, which is having the double bond. Please pay attention. Here is the double bond. First carbon having what? Two hydrogens. So as soon as I see the two hydrogens attached, yeah, I'll understand they can't have cis trans isomerism. एक कार्बन के साथ दो क्या आ गए? Hydrogens. Because अगर आप इसको गौर से देखें तो ये cis भी है और ये trans भी है, which is not possible at one moment. So, but you don't need to go into the detail. As soon as you see these two hydrogens here, so you will understand it's a cis and trans isomers. Okay, cis and trans isomer. Okay, no cis trans isomerism. Okay. Okay, next I'm going to give you, please, CH3, CH double bond. Please draw the cis trans isomerism in the following compounds. This one, number 5. Please draw the cis trans isomers.
This is trans both.
Yeah, you have to draw the cis and trans.
So ये CH3 फिफ्थ में C लिखा हुआ आपने
जी
C स्क्वायर के बाद
जी it's C.
फिर दो फंक्शन मिक्स हो तो पहले कौन से लिखते हैं?
Anyone? देखो भाई गार्ड को 4 yes 5 नहीं है. In 4, if you write these two carbons, there is a 1 H and 1 CH3. There is a H and then COOH. So yeah, what is this isomer? Cis?
Cis, and the other one is trans. Cis. To have
What is this?
cis, this one is not possible. Fifth one is not possible.
Why not?
Cis,
As soon as you draw this, you understand there are two what CH3s attached. So as soon as you see two same atoms or groups attached with one carbon having the double bond, it cannot have cis trans isomer. Two same groups, na? Two CH3s attached with this carbon having the double bond or carrying the double bond, so it can't have cis trans isomerism. Although the other side have two different, but both sides should have two different atoms or groups. What about 6?
it has. Yes, sir. It has.
If you look at carbon double bond, what is with the first one? H and F. Are they the same?
Yes, no.
What is this? Cl and Br, are they the same? Then why don't they have it? Yes, it would have cis trans isomerism because carbon double bond be here and both carbon having two different. Now the point is that I'm not being able to understand is it cis or trans. It has some different rule that is called EZ configuration. And although it's not the part of the syllabus, but I just want to let you know that is how you call it an cis and trans. You look at their atomic number. The first carbon have two atoms, one hydrogen and one fluorine. Hydrogen's atomic number is 1 and fluorine atomic number is 9. Which one is smaller? So we am going to assign number 1 with the hydrogen and number 2 with the fluorine. Similarly, if you look at these two atoms, chlorine and bromine, what is the atomic number for chlorine? 17, and bromine is what? 35. Which one is smaller? So chlorine is 1 and bromine is 2. Now you have to see the numbers you have assigned. Are they same numbers on the same side? So this is the cis isomer. But as I said and repeat myself, this how I assign these numbers. This is a different naming, different way of naming. That is EZ configuration. That is not a part of the syllabus. But I wanted to let you know that when there is a double bond, all 4 are different. Even then it would have a cis trans isomerism. Okay? The rules are different to assign, but they would be there. So they can ask you to now, if somebody told me this is isomer, how can I make a trans isomer of this? Yes, just flip the next carbon. So it would be a trans. No, but what about this if there are two double bonds? What about this if there are two double bonds?
This will be a cis.
What about if they have two bonds, Bacho? If it has two bonds, then what do you think?
We look at each bond separately.
Yes, if there are more than one covalent bond, double bonds, so there'll be more than one positions where the double bond will have the restrictions. Am I right? So if you look at this, for example, please pay attention. In this compound, so there are two places where there is a restriction in the double bond. One here, H, this is CH3, this is H, this is what? CH2. And then again, from here, the second molecule or second wo start ho jata hai. So here it is COOH. Now look at this. Now this is the molecule. The first double bond restricts the free rotation and the two similar atoms are on the same side. So as per first orientation, it is cis. But if you look at the second one, again the free rotation is restricted and two similar atoms are on the same side. So this is known as cis-cis isomer. Cis-cis isomer. Now, because there are two double bonds, so there are two restrictions, right? For example, I can show it by means of a video. Not a video by जो लोग Zoom पे हैं, they can watch the window of a video on my side. I need your help. Can you come here and bring a pen? Now, first you need to understand one thing. Now I think you can see my camera. एक पेन आपको यहाँ खड़ा होना है, excuse me. ये पकड़िए. Now, what is the cis trans? Look, when two similar atoms, look at this. When two similar atoms, parents, this is just for the sake of imagination. These two are the chlorines. They are on the same side. Here is the double bond between, here is the double bond. So when two similar atoms are on the same side of double bond, this is what? Cis isomer. If I switch it here, right? And what will be this now? Trans isomer, in which the similar atoms go on to the opposite side, right? So this is cis, this is trans, right? So in these molecules, let's say this is C2H2Cl2. When the two chlorines join with two carbon on the same side, cis and trans. So out of 100 C2H2Cl2, 50 were oriented like this, and the other 50 were oriented like this. Because of that, they develop a different intermolecular forces, different attractions, different melting boiling points, so they become two different compounds. Do you get it? Now, once the carbon chain increases the length, and it gets more than one places where there is a double bond. Right now, you have to. Where's the other pen? Your pen. Yeah. Now, no pen we need. Now, if you see that there is, hold it like this. Here. So here we see now this is one molecule, this is another molecule. So this is cis isomer. If we flip it down, it will be a trans isomer. But once there is a double bond, so now let's say these two molecules are joined together. Look. ऐसे ही रखो जैसे पहले रखा था. No, ऐसे नहीं. Yeah, now here. Now here is the double bond. There is the double bond. So now what is this orientation? As compared to this double bond, what is this orientation? Cis. Now you twist down. Now is the orientation changed now? Cis trans. You come in here, you put it down, and I put it down. What is this orientation now? Trans. Okay, now you turn back. Trans cis. Okay, so the first was cis. Second was cis trans. The third was trans, and now trans cis. So how many orientations we have originated? 4. So this is the molecule which look like this. There's a 4 different orientations in which one side is cis, other side is trans, one side is trans, the other side is cis, one side and other side both cis, one side and other side both trans. Right? So sit down. Thank you. Double bond is only restricted now. Sorry?
The double bond लगा हुआ है. ये दो different molecules.
No, this is a one molecule which is connected together. I just put another bond between these two. So they are connected together. This is cis. Now please pay attention. I'm drawing the same molecule again. Look, here is the H, here is CH3, here is H, here is CH2. Now look at on this side. This double bond and H goes up and COOH comes down. So what is this now? Cis trans. What will be the other one? Yes, one more like trans cis kar lete hain. Yes, if we put hydrogen on the top and CH3 here, H here. Now what is this now? Trans with the first, second वापस cis कर देते हैं. What is this now? Trans cis. And the last one क्या होगी when both are orientations are trans? So this one is also trans. And this one is also trans. Okay, so this is trans. Okay, so how many isomers cis trans for this compound? Four isomers, right? If they ask you to draw, this is how you draw and figure out. But there is a short way to just, if they ask you to only tell the number, then you can use their formula. The number of isomers is equal to 2 base hai, raised to the power number of double bonds.
2 to the power 4.
2 to the power 2 होगा ना यहाँ, तो कितने हो गए 4. 2 to the power of 1 double bond है तो 1. So इसी तरह if there is a molecule, 2 raised to the power number of double bonds. For example, let me explain it. For example, this is a compound CH3, CH double bond CH, CH2, CH double bond CH, and then CH3, CH double bond CHO. Now let's say, for example, please pay attention. If somebody asks us how many cis trans isomer for this, we are using the formula. Number of isomers is equal to what? 2 तो base नहीं change होगा. और कितने double bond है इसमें? How many double bonds?
8.
तो 2 raised to power 3 कितना हो गया? 8 isomers. And by the way, which 8 they were? Cis. And then cis, trans. Trans, cis, and so on like. Okay? No, this is we are saying, look, you have to follow like this. If it would have one more orientation. And that also goes like this, similar atoms are on the same side. In this molecule, if it extends to give one more orientation like this. So this isomer would be called what? Cis. This is what I said. Okay? And then if that orientation only turns trans, but the other two remain cis. So that will be a new isomer?
Yes, sir.
Which will be cis and trans. But as I said, excuse me.
Sir, ये मैं स्कूल में पढ़ने थी अब यहाँ भी पढ़ने थी.
Yes, please.
Sir, I said आप इसको कैंटीन का.
I need your attention, please. Yes, please. Undivided, absolute, honorable. Okay, so this is okay. Gigi, please. Similarly, they. Okay, so at times they also ask you to draw the cis-trans isomers in skeletal formula. Skeletal, right? For example, pay attention, everyone. Pay attention. If we have butene, please pay attention. Stop writing. If we have butene 1, 2, 3, 4, and they ask us to draw the skeletal structure mein cis-trans, how it would look like. Can you see? If you look at the skeletal formula, so it means here is a carbon-carbon double bond. right? And there's a one carbon on this side, this one.
तो सर ये वो
And there's a one carbon on this side, this one. So I, on purpose, drawn both carbon on the same side of the double bond. Hydrogens are there, but we can't see the hydrogens in skeletal formula. So we have to look for the cis trans in skeletal using carbons only. So now these two carbons are on the same side of the double bond. This is called what? Cis isomer. Similarly, for the same thing, trans isomer kya hoga? Let the first one on the top and the second one. So this is what? Trans isomer. And by the way, what we use to draw the butene in a skeletal formula like this, na? So the one which we use to draw is naturally, if you see, it's a trans isomer. So the zigzag ones are always the trans isomers, right? Yes, or you can draw them like this. Now I'm going to give you one more. This is pentuene. Can you please draw the cis and trans isomers in the skeletal formula for pentuene if it has the cis trans isomerism?
इंस्ट्रक्शन भी लिखे ना एक बार
तो आपने खुद बनाना होगा. Pentuene, please draw the skeletal formula using. Anyone?
Yes, done.
So pentuene is like this. This is pentuene. So if I draw the skeletal and double bond here, how many carbon with the left side of the double bond? One. And what about here?
and then
Here, or straight you can draw. But initially, once you look at the double bond, the two carbons are on the same side. But this is the cis, yeah, both ones can also go down.
Exactly.
Or this one, yeah, you can draw it like this. So these two are the cis isomers.
ऊपर एक नीचे
Now, if I draw the trans isomer, then we have to draw one on the top, one down here. This is the trans.
ऊपर है ना चौके स्ट्रेट लाइन बनाइए वो अगर हम नीचे बना दें
Doesn't make difference.
सर
These two, ये जो जहाँ डबल बॉन्ड है, यहाँ से अगर दोनों सेम साइड पे निकल रहे हैं तो cis isomer होगा.
एक लाइन एक कार्बन ऊपर जाए एक नीचे जाए
No, there is a one carbon attached with this, ना? वो तो अगला इसके साथ आगे attach है.
सर देखिए ऐसे ऐसे इस तरह से
No, first you have to draw the look pentuene, na? If you look at the pentuene structure, I think pentuene structure is wrong. You have drawn. This is CH2. This is CH3. No, this is one. No, this is a branch, na? Pentuene नहीं बनाया आपने. Pentuene में ये carbon carbon double bond है. Then CH3 और उधर CH2 CH3 है. आपने दो CH3s attach कर दिए. Okay. And when there are two CH3s, they don't have cis trans isomerism.
When they have
Okay, you have to show the skeletal formula of 2-methyl butene. Cis and trans isomers. Okay, 2-methyl-butene. First, we have to draw the structure 1, 2, 3, 4. And here is 2-methyl, and here is butene. Okay, here is CH3H and CH3. Now, as soon as I draw the normal formula, I can see the two carbons, the two similar groups attached. So I know there's no cis trans isomer.
Oh, yes.
Right?
Say,
There is two CH3s here. Right? So there is no cis trans isomerism because two CH3s attached. But you see the two similar groups up and down are CH3s. So if two CH3s are there, you cannot have the phenomena of cis trans isomerism.
I didn't write it.
G. Please. So, okay, now, yes, that's all about the cis trans isomerism. In cycloalkenes, yes, there is a phenomena of cis trans isomerism, but only when there are substituent group attached. If it's just cycloalkene or cyclobutene, cyclopentene, they don't have cis and trans isomers, right? Because then they have the similar, they can't have a different groups attached with each other. For example, if I look at this, so it can't have cis trans isomerism, okay? Although there is a double bond until the different groups are not attached here, right? So cyclohexene, cyclopropene, their trans structures have too much strain on them. It's like this, na? If cis trans kya hota? Similar atom, same side. Now, if you imagine this, so its double bond is connected this. So the whole ring, if I put it like this, so the whole ring is gonna go up and down. Like ये इस तरह जुड़े हुए हैं ना यूं, तो अब एक नीचे नहीं जा सकता ना ट्रांस होने के लिए, ये पूरा ही नीचे जाएगा. Cis trans, no cis trans isomerism in simple cycloalkenes. Okay, so that's all about the cis trans isomerism. Now the other type of isomerism is optical isomerism. We'll continue this. यहाँ रुक जाते हैं. Optical isomerism. Right? So the other type of isomerism is optical isomerism, right? जिस तरह cis trans, या चलें कल ही इसको introduce करता हूँ, right? Thank you.